Video number 15 in the SEER H orientation series. We are looking at the electronic board and assembly work element at the moment, and this time we'll be looking at the key technical performance inputs. And these are here. So this is where they reside in the parameter view window, right at the top. We looked at the technology. We know that the technology is controlling the performance parameters here that we need to review, populate, either via the application knowledge base that you've selected, or by better knowledge that you have at hand when you've updated the inputs. So you'll see the list of available inputs over here on the right-hand side. So major components, COTS, modified components, minor components, and you'll see these are here. And then other ones as well. So this is a controller, and this has different to what a power supply would be, different to what an assembly would be, and so on. So this is what's changing every time. So we're just going to give you a brief insight into the sorts of things it's asking for, and let's take a look at them, how they work. So this is a list of the different technologies across the top, and then these are the questions that are being asked by the model when it comes to the parameters that we're looking at today. So major components is common across everything. COTS modified is common across everything. Minor components is common across everything. Power density and efficiency are only found in power supply. Receiving, maximum operating frequency is in receiving, transmitting, amplifiers, conditioners and synthesizers, filters, transponders, and so on. So this gives you a matrix of where the questions will appear. So external data rate, you will find it in these ones at the end. But, and this one here, gain, there's this 3 with the little X's in here. So let's take a look at the model and see how that translates. So this is the boards we were looking at. So we're still in boards. This is a power supply technology. And you can see that it's got major components, COTS modified components, minor components, power density, and efficiency. We saw that on the matrix earlier. Double click. So we're looking at things like op amps, voltage regulators, microcontrollers, microprocessors, complex chips such as DSPs, FPGAs, and ASICs are not included. These are specialist chips, and these are captured over here under custom component usage, okay? So if you have any of them, don't include them as a major component, add them into the subsection, which will be covering in another video quite shortly. COTS modified components, so major components that we have bought in needs to be modified in some way to make them work for our board. So they're listed here. Minor components, all the little things that go on within on the board, or your lost that resistors, capacitors, inductors, etc. And there are all the sorts of things that get included here. So hence the high number. We're looking at the power density, the power density, the amount of output power per unit volume, and the efficiency of that system and the power drawdown. So that's all the inputs are here. So if we switch to receiving electronics, then I've highlighted in blue the only ones that have changed from the power supply. Some have gone away, some have come in. So we now have max operating frequency. Let's have a look what the help says. So it's the radio signals that the board transmits and receives for a single frequency. Set the input to the highest frequency. Okay, there's some examples here as well, hidden away in the help. So if you're considering it, please take a look at this for guidance. The knowledge base will be putting you on the right ballpark, but you may want to finally critique it, reduce the difference between the least likely and most maybe, and do it. The operating frequency range, again, if there's any extra effort associated with designing the board that operates on different frequencies, such as a multi-frequency board, use the operating frequency range to reflect the widest frequency range spanning across the various frequencies, taking the difference between the highest and the lowest that the board is expected to operate at. And again, all of this is here within the help. Transmitting electronics. Again, we got two new ones again. We got power and we got gain. So power consumption, average consumption, power of the board or assembly. And this applies to transmitting electronics, assembly and navigation, processing, assembly for control, and so on. So that's that one. I click on next, we can jump down the parameter list. So this time gain is the increase in signal measured as a ratio to the output signal to the input signal for RF use, power gain for all else use voltage gain. Okay, so it's the guidance for that one. RF amplifiers, nothing new in that one. Controllers, synthesizers, so these are all the same as you've seen before. RF transponders, power gain. So this one's got external data rates. This one's got internal bus speed and the number of input-output pins that we're looking at on this one. Computational, nothing new there. Backplanes and interconnects, exactly the same, data rates, etc. Controller, we've seen all of them before. And the signal processor, the same. So that is the inputs for the boards. Now for the electronic assemblies, we got weight, that we discussed the other day. So we need to know the overall weight of the black box that we're estimating. So that's going to include the harnesses, the board, the enclosure, the power supplies, and all of the things that you anticipate will be going on within that piece of equipment. Estimate the number of total circuit boards that we can see. There'll be connectors. You can gauge it by the size of the box. Input the power required. Number of custom boards, if any, difficult to judge, but you will be able to judge the printed boards and the speed in megahertz, which we need to look at as well. For processing, again, we got the weight, total number of printed circuit boards, the power, number of custom boards, and their speed. For control, so these are all very common. That's exactly the same. RF communications. This time we've added in bandwidth. So we need to enter a bandwidth for this type of board. And for this one, we have, let's go back, bandwidth. So we got custom boards again. We got input power, output power, number of power levels that you would anticipate on the board. And again, it's operating speed. And finally, similar again, assembly weight, total number of printed circuit boards, number of custom boards, the power input, power output, number of power levels, and speed. So that's the inputs for the key technical performance parameters. This is the, and everyone has its own guidance, so we don't need to worry about them. So we go back. Just a reminder of where these questions will appear in the list. And once again, thank you very much for joining us today. I hope that's of interest to you. Please visit galworth.com, have a look at what's new. If you need any help or support, training, support at galworth.com. Sales and product inquiries within the Americas, contact Chris. And for sales and inquiries outside of the Americas, contact David. Once again, thank you very much for your time and look forward to seeing you in the next video.